Any other ones as you are looking at questions up here that we need to take a look at? So 7 we took care of. Is this number 1? Is that what our question is, number 1? Number 1, when I look at that, I'm going to start it, but I'm not going to do much more. But you are looking at your like terms with that. And if we are working with our like terms, what you should have been looking at was taking, as we are looking at this one, it's 19, and then you are taking and you're subtracting. And so if you are looking at that and you have a negative, in this case, h and a negative h, that's like a negative 1h, and then plus a negative 1h. So if you are looking at these like terms, that's really like plus a negative 2h equals negative 13. And then you are subtracting 19 from both sides. And you should have been able to solve for that, okay? But negative h and a negative h is not 0. It's negative 2h in that intersection, okay? From the text, so the story problem. So what we are going to turn in today is we are going to turn in your page 91. 11, 17, 19, 21, and 23 to 25, which are the story problems. And so what I was looking for here is that you told me first what was your variable equal to, and then you wrote an equation, just like we did in our notes, and then you solved it. And after you solve the question, then you answer the question, okay? So the x might be your solution, like what was x equal to, and then you answer the question to the story problem, okay? So if I was looking, it said number 23 was a question that we needed to look at. If we are looking at 23, first off, what would you identify as your variable if we are taking a look at number 23? As you read through the problem. Whitney, what would you tell me the variable is? So what are you trying to find in 23?
Oh, how many boxes you can...
Trying to find how many boxes. So 23, first thing I'm going to find x, or maybe I want to even use b, but b to me looks like a 6, so I'm not going to use b. So x equals, and what we were trying to find was how many boxes of books were delivered, right? So boxes of books. Okay? Next, Jacob, we want to try and write an equation. Reading what we know, the delivery person uses elevator bring boxes up to the office. The delivery person weighs 160. Each box of books weighs 50, maximum of 1,000 pounds. What are you thinking for your equation? Any idea what you'd start with? Jacob? Yeah, any idea how you'd start it? Your equation?
50 plus 160.
Okay. 50x. Do you guys agree with 50x? Yes. Each box weighs 50 pounds. So the weight of the box, right? That's our weight, times the box, plus, that's going to tell us how many of them we can have, plus my person weighs 160. And what's the capacity of the elevator? 1,000. So, I have just identified my variable. I've written the equation. You guys okay solving? Yeah.
Would it be okay if you put like 50x plus 160 is less than or equal to 1,000?
I would take it as an inequality for this one. But we were mostly working with equations, so yeah, I would take it as an inequality. So you could have it that, both. You could have less or equal or the equal. Yes. Okay. So if you didn't finish those, as soon as we are done with going through the lesson today, you want to finish this first. You're turning this in before you leave today. If you know you already have all of this page 91 done, keep in mind the steps, because some of you are like, I don't get the steps, I'm not sure. So step 1, when you are looking at solving equations. Possibly use the distributive property to remove all grouping first. So when you are looking at it, if you have grouping symbols, you want to eliminate those first, right? So you're going to maybe use the distributive property. You might want to clear your decimals or your fractions. We did that today. Some of you probably didn't clear the decimals, and a lot of times I don't know that clearing decimals help, but you can multiply by 10, 100, 1,000 that equation on both sides, and then you don't have any decimals, right? That's kind of nice sometimes. Do you have to do it? No, because you have your calculator usually you're doing this. But the fraction part, multiplying by that least common multiple, that's probably a good idea. When we look at then combining our like terms, that's our next step. So after we've gotten rid of our parentheses, we might want to add our like terms, and that's usually on one side of your equation. Use your properties of equality. That's usually going to be addition and subtraction first, and then my last step is going to be to use the multiplication or division property, and then to check with the original. So, if we are looking at this problem, we have variables on both sides. My hint when you have variables on both sides is always get rid of the smaller variable. I don't like moving it to that side. I know, but this is going to be nice when we start doing our inequalities at the end of this unit. So if I always get rid of the smaller one, I'm going to do that first by subtracting 2x from both sides and an equal sign. If I was asking for the property, this would be the subtraction property, right, of equality. Subtraction property of equality. And most of you are going, oh yeah, I remember how to do this, right? And you get 3x plus 2 is equal to 14. And Caden, in the middle, my next step.
Then you take minus 2 and minus 2 equals 14.
Yep, again, subtraction property, right, of equality. And what'd you get when you do that?
12.
So 3x is 12. And Micah, if I'm solving, I'm going to do what next? Divide 3. And I get my answer, x is 4. And it says, well, you should check it. And just to show you that when you're doing a check with this one, Sanjay, tell me what would I do for my check?
You replace the x with
So tell me what to write. 5 times
5 times squared plus 2 equals 2 times squared plus 14.
So we know 20 plus 2, right? 8 plus 14, same thing. It checks. Now, someone said, I didn't realize that the answers were in the back of the book when you're doing your textbook. Our textbook has the answers in the back, so you can definitely check your answers in the back. So this is what the question will look like where I'm talking about those properties, okay? You will be asked on this test, you will be asked on your final exam that we take to do something like this. I'll give you a bunch of properties and say, well, what's the property? What happened from the first line to the second line, right? So in this case, what did we do on both sides of the equation, Evie? On both sides, from the first to the second line.
Take away 4k.
So that would be subtraction property, right? Subtraction property of equality. Okay? And Mallory, what happened from the second one to the third line?
They combined the like terms.
Added like terms, right? Could you also say simplify? Yeah, I like adding like terms a little better because it's more specific. But that is what you're doing. You're combining your like terms. All right, so now from this line to down here, if we are looking at it, Gavin, what are we looking at doing? Subtracting again, right? So subtraction property of equality, right? If we are looking at that. All right, if we continue, Dylan, to get from this line to this line.
-2. Plus.
Okay, so from here to here, this is where we subtracted the 2 on both sides, subtraction. So now I'm looking from this step right here. How did I get from here to here and from this to here? What happened? What did you do? Because here I have 3k plus 2 minus 2, and now I just have 3k. What did we do?
I can't tell you, to be honest.
You can't. Abby, you have an idea? Yeah, you're just simplifying. You're adding like terms, or you're simplifying, right? So all we did was we added -2 and +2. This actually does have a property. It's called the addition property of adding opposites, and that gives us 0, but we don't have to worry about having that one up here. So now, after I simplified, and I go from here to here, Katie, what am I doing? Division property, okay? And then my last one, all I am really doing, Soren, is again, simplify. Okay? And that is as simple as giving those properties is going to be when we take the test with this. It's going to be just that. Explain what you did, show your work kind of thing. Okay? All right. So again, we want to identify our variable. Okay, so first off, an office manager spent $650 on a new energy-saving copy machine that will reduce the monthly electric bill from $112 to $88. And again, do I understand that you could possibly write this and do this problem without ever writing an equation? Yes, I think you probably could. Write an equation to model it. I need to see the equation. So if we are looking at this, Owen, what do you want your variable to be? What are we trying to find? What is my x going to equal if you want to use x? What is my variable in this problem?
Your variable should be the difference between 112.
Okay, but I don't want to. I want. What are they asking us to find? So write an equation to do what? What are we trying to find in the question down here?
The amount of months.
We're trying to find the amount of money that we're saving, right? Dollars saved, something like that, right? So we're really trying to look at how many, because it says, if we write an equation to solve and find how many, are we trying to find money or how many months? Months. So X is going to be the number of months, right? Number of months what? Takes to save money. The number of months to save or to pay for the copier, right? That's what we're looking at. So read the question. That's usually going to tell you what your variable is. The number of months to pay for the copier. Okay? So once I have down that that part is, Josie, do you want to try writing an equation? So we know right now we are spending how much money on our bill? What do you know, Josie? So he spent $650, right? $650 is our new copier. Plus, how much were we paying before if we are looking at our bill? Do we want to have plus 112 or plus 188 or plus 88? Because this is the new one, right? $88 a month, right? My monthly electric bill will go from 112 to 88. I used M because I was thinking of months. I don't care if you use M or X, right? To me, months make sense in the problem instead of X, but I would take it either way. 112X. Does that make sense to everyone? We're going to subtract our 88M. $650 equals 24M. Divide, and the number of months it's going to take us to pay for my copier. M equals. Okay, calculators out. Make sure you have your calculator with you every day. Bring them, use them, have them on your desk. If not, grab one up here. Start bringing your own so you have it all the time. So M is equal to 27. So a little over how many years? A little over 2 years, right? So the answer is number of months to pay for the copier. The copier will be paid for. In 27 months. And hopefully you got a good warranty with it, right? So they're going to come and fix it and do whatever they have to do for it. Okay? Last year you solved some problems where you had no solution and infinitely many solutions. We're going to do the same thing as we get into these equations. So this kind of is review, okay? This is review of what you guys did last year. So at the top of the page, if you are reading, Caleb.
When you're solving an equation, sometimes all the variables cancel out and you are left with a true numerical statement, also known as an identity, or a false numeric statement.
So our true statements, that's when we have infinitely many. That's when 0 equals 0. 4 equals 4. 2.5 equals 2.5. All true statements. You agree? If you get a problem and it's false, you end up with 0 on one side equals 4. We are going to write no solution. You will be not telling me it's an identity. You will tell me if it's true that there are infinitely many solutions because everything you pick will work. Okay? If you have a false statement, nothing you pick will work. It doesn't matter what you pick. So, 2 equals negative 2. That is a false statement. Okay? So they show you some examples here. Here they distribute. And notice they get 10x plus 12 equals 10x plus 12. If you would subtract 10x from both sides, you end up with 12 equals 12. My answer is infinitely many solutions. Okay? Take a look at the next one down. You add like terms and simplify, and you get down to negative 4 equals 5. Negative 4 equals 5 is not true. Our answer is no solution. Over here in the side notes, if you would please read in that side notes, Liz.
If you eliminate the variable in the process of solving, the equation is either an identity with infinitely many solutions or equations with one.
So keep that in mind. If the two numbers come out the same, you are going to have infinitely many. If it does not work out, so please try. Let's do the people over here by the window. You're going to, everyone, start with this one in the blue. So this is my window. People are going to start here. Okay? People in the middle, you guys are going to do this one, so we don't have to have everyone do each one, and then we're going to put them up here and you'll be able to see. If you finish yours, go to the next one. Okay? Here we are going to have the middle people doing this one. And over here we're going to have the people over here by the door. So, do this one. So you really only have to do one problem. Make sure you watch for this last one. You're distributing a negative 1, right? So be careful for those people. Go. And you do that one. Do the one in the middle. When you think you have your answer, raise your hand. We're going to start, and then go to the next one. So do you want to put up for the first one? There's a pen right up there. Okay? Yep. People in the middle. Liz, you got yours as soon as she's done? No. I don't think so. Keep going. Go back. Let's see what you do. So 28 minus 7 minus 12. So, yeah, solve it. Subtract it. Yeah, you're doing the variable work on that. Yeah, show that one when she's done. Yes, thank you. Here. Okay. Anyone over here have theirs? And you can write it down further. You don't have to write it right by it. And here's my, so you can write right down here. I don't care. You don't have to write it out by it. Yes, and you got to show me why though. Let's subtract those from both sides, right? So that you got a false statement. I want to see the false statement. Yeah, the X is from both sides. Okay. so I can see the false statement, because or else it's not really false statement, right? If you finish yours, what happened to your variable? Like when you solve the problem. Okay, you don't want to do it that way. You but Sanjay's going up first. So I just want to show one thing up here. When you were doing this problem, you would have, I hope, showed me that you subtracted 12b from both sides. And then you show me that you got -6 equals -6 so that you can write this. I want to see the true or false statement. If you don't get to that point, I need to see that. Okay? You can write it just right down here. Okay? Hang on a minute. And one of them is right here. And most of you in this middle group did it right. And when you came up here, this was done correctly. You distributed and got -7a. On your paper, this is what I saw. 28 minus a equals 3a minus 12. Okay? And the reason I wanted him to put it up, because he got an answer, and did you ever check the other answer that you got? It looks so nice that it had to be right, right? It was a nice number. He added a to both sides, and some of you will do this. You forget to distribute, and you get 28 equals 4a minus 12, right? You add 12, and you go, well, of course, it's a nice number. 40 equals 4a. It's 10. It has to be right. I'm not going to check it. It's a nice number. This is why the check on every quiz is so important, okay? Because it is so easy to get the wrong answer, okay, when you are looking at that. It is so easy to make some little mistake and think you did it right. Now, when he came up here and he didn't take his paper, he did everything correctly. He distributed and got it right. And those of you, when you're doing this, again, just so quick to check 4, right? If I plug in 4 here, right? 4 minus 4, that's going to be 0. 0 times 7 is 0. 4 minus 4 here, 0. 0 times both sides. Whereas if the answer was 10, 4 minus 10 is a -6. -6 times 7, -42. 10 minus 4 is 6. That's not the same as 6 times 3.
Would you distribute the 7 among?
Yeah, he did it, what I'm saying, he did it wrong. So if you get this answer of 10 and you're checking 10, this is why I'm kind of a picky person on make sure on the quiz and test, because you think it looks so beautiful that it has to be right. But when you do 7 times 4 minus 10, that's going to be 7 times -6. That is not the same as 3 times 6, right?
When you distribute the 7, so it'd be 28 minus 7.
I know. I said he did it wrong, and many of you will make this mistake, so I'm just showing you that when you do it wrong, yes, this is the right way in the pink. I'm just saying that that's why the check is so important, okay? So when you get it wrong on your test, and you put down 10, all I'm saying is it's easy for me to mark it wrong if you're not doing the check. Go back and plug it in and do the check. This next one, I had some, when I looked at his paper originally, this is where he stopped. I need to see, again, just like I do over here, I need to see that the statement is false. That 0 does not equal 4. That's where you're going to stop. All right. So page 105 is where you're doing your work. On page 105 in your textbook, everyone should have their name in the front cover of their textbook. If you don't, make sure you write it in. So, leave room, and where it says check your answers, so you are doing 11 to 17 odd. Answers are in the back, so you can check them. But I would say in this 11, 13, 15, 17, I should see on your paper 2 checks. I don't care which 2 you want to check, right? Then you are doing both 19 and 20. Again, what do I need with 19 and 20? I need to know what is your variable equal to. Then I need your equation. Then I need your answer.